Hello, welcome to chapter 21 in Trump. My name is Evan Sasamadu from Environment Language today. So before we get started with some practice problems, let's go ahead and learn more about the IGV. IGV simply stands for the Integrated Genome Viewer. This program will allow you to view DNA and protein sequences, but it does not allow you to edit the sequences that you have. In this video, I'll be showing you all you need to know about the IGV to be able to solve some problems. This is the chicken lysosome gene. This is a perfect example to show how IGV works. First things first, let's look at chromosome 1. Chromosome 1 is right here. Just follow the arrow. This bar indicates where we can see the gene that we are looking for. So chromosome 1 in all have about 100 genes. But we're going to be looking at only one lysosome today, which is shown in the red bar right here. We all know a gene is a small part of a chromosome. So to see the details of the gene, the lysosome gene, we will first need to zoom in to find the gene view. So this whole entire section is the gene view. Then we can even zoom in more finer to find the sequence view. So this entire section down here, if you follow the arrow, just like it's this whole entire section is the sequence view, and this top part is the gene view. Now let's go ahead to see what we have in the gene view. This part is very important to know because it's the basics for every problem that you solve. So first, we have the promoter region right there. This is the promoter. There's an arrow pointing the right. Then we have the 5' UTR, which is the gray right there. It's UTR stands for the 5' untranslated region. Then when you come down here, this small part will show you start codon. Then we have our exon 1. Exon 1 is right there. This is exon 1. This whole part, this whole blue part is exon 1. Then we have intron 1. Intron 1. We have exon 2, intron 2, exon 3, intron 3, then that should be our exon 4. Then right after exon 4, we have our stop codon right there in between the 3' UTR and exon 4. So we have right here, this is a 3' untranslated region. The stop codon is right there. So let's take a look at the sequence view. What do we have for the sequence view? So this down here, as I said before, is the sequence view. From just looking at the sequence view, you can just tell the RNA polymerase goes from left to right because you can see 5' to 3' right there, and the 3' to 5' based on where you're looking at. So from this, we can just tell that the bottom strand is the transcribed strand, and the top strand is the coding strand. So this top strand is the coding strand, then the bottom is the transcribed strand. The good thing about the IGV is that it shows you all the possible translations of the mRNA depending on which reading frame is used. So we know that these green boxes with the M is your start codon. This is very important to know. M is methionine, which is your start, depending on which reading frame you are using. The red boxes shows you the stop codon, also depending on the reading frame which is being used. These letters here gives you the single letter code for the amino acid. Now, how do you tell which frame you're using? Look above to see the protein sequence and find the corresponding frame below. So valine, leucine, alanine, it's in the protein sequence. So to find the corresponding frame, you just have to look down, go all the way, continue down. You see CTG codon in the DNA. It's CTG, which becomes CUG in mRNA. If you look up in the codon table, you see that CUG is Lu, as you expect. The reading frame stays the same in each exon, but it may change when going across an intron. So we have leucine, which is in the protein sequence. When you come down here to the DNA, you see CTG, but in the mRNA it becomes CUG. Let's go ahead and solve some questions about the IGV. The first question is asking, give the index number of any one of the nucleotides in the start codon for this gene. The second question is, give the index number of any one of the nucleotides in the stop codon for this gene. Okay, so the first thing I'll do is just go ahead and to highlight the exon sequence. This shows me where it's going to start and where it's going to stop, so it's pretty easy to know. So we know that the start codon should be right here, since the green M codes methionine, and it's the beginning of the gene, the start. So it's pretty easy to just choose where it's at. So the base is 30, but 29 and 31 also could be right, because since we don't have one definite index number, it says we could choose any one of those. So let's go with 29. Then now we have to scroll all the way to the end of the gene to find the stop codon. So as you scroll, you can see this. So we're just trying to get to this part, which is the last part of the gene. Scrolling is pretty fun. You just have to keep going and try not to go outside the range. Stay in the range, because when you're coming back, it's just hard to come back. So just try and stay in the range and keep so smooth and let it just go. So you get in there, get into the last part of the gene to find our stop codon. Since we already highlighted the sequence, we can just tell where the stop is, where the last stop is at the end of the blue line. So just right here. So there's no more stop codons, so we are done. This is the stop codon, TGA. So anywhere between 3582 to 3586 is correct. So let's just choose 3582. 3582. Let's check our answers. Yes, we are correct. Got my heart